Hey everyone, it's Miss O'Donnell. So we're going to learn our new angle today called intersecting chords. All right, so far we've learned two. We've learned our central angle, which is in blue, angle BAC. Those are located at the center of the circle. They're created by two radiuses, and those are equal to the arc. So angle BAC is congruent to arc BC. Then the second one we learned are inscribed angles. Those are the pink ones, EDF. Those are formed by two chords that share an endpoint. And inscribed angles, you'll remember, are half of the arc. So angle D is half of arc EF. So those are the two we know so far. We're going to learn a new one today. So what I want you to think about is what happens if the chords don't share an endpoint. So BD and CE are both chords, but now instead of sharing an endpoint like this angle EDF, they both share D. These intersect somewhere inside the circle, not at the center, but somewhere inside the circle. So we got to think about what our formula is going to look like. So some things to notice. Angle BAC and angle DAE are vertical angles. That's these ones right here. And we know that vertical angles are congruent. So we know that these two angles have to be the same. But arc BC does not equal DE. So I threw some numbers in there. So BC is 40 degrees, DE is 60 degrees. So if we use the same rule as central angles, that would mean angle BAC is 40 degrees and angle EAD is 60 degrees. And that can't be true because the vertical angles have to be equal. These two have to be equal and they're not. So we can't use the same as central angles. We also can't use the same as inscribed angles. So inscribed angles are half the arc. So if I took half of BC, half of 40 is 20, half of ED is 30, they're still not equal. So we can't use half the arc. So we're going to have to come up with a brand new formula. It's going to be similar, but the new formula is that the angle, those vertical angles, are equal to arc 1 plus arc 2. We're going to take the two arcs. It doesn't matter which one you put first. You're going to add them together. Then you're going to divide by 2. So an example of that would look like this. So if we took our 40 and 60 from earlier, we would add them. 40 plus 60 is 100. 100 divided by 2 is 50. So now BAC and EAD are both going to be 50 degrees. So that's intersecting chords, right? Two chords that are intersecting. That's why they're called that. But now they don't share an endpoint and their angles are not at the center. So they're somewhere else inside the circle. We're going to use the formula angle equals arc 1 plus arc 2. We're adding the arcs together and dividing by 2. So I'm going to go through some practice problems with you. Here's your first one. So I want you to pause the video, grab your calculator, try to solve for x. So you should have used your formula. X is the angle, so we want angle equals arc 1 plus arc 2 divided by 2. Our two arcs are 133 and 67. I'm going to add them together. I get 200 divided by 2. X is going to equal 100. So I added my two arcs. I divided by 2. Here's another one. Pause the video, try to solve for it. Should have used your formula. Angle equals arc 1 plus arc 2 divided by 2. Add together your arcs. 204 plus 50 is 254. Divided by 2, you get 127. So that angle, both UTV and CTW, are both 127 degrees. So hopefully that's not too bad. It's just one extra step for inscribed angles. Then it gets a little bit harder. So I want you to take a second, try to figure this out, pause it, and then I will give you a hint in just a second. So your hint is that you should have written down the formula. Angle equals arc 1 plus arc 2 divided by 2. You should have plugged in everything you know. So plug in where should x go, where should the 91 go, and where should the 57 go. So pause it again, try to figure it out now. All right, so you should have seen that our angle is 91. So we want to plug in 91 for our angle. Arc 1 and arc 2, it doesn't matter which one's which. So I'm going to call arc 1 57 and arc 2 x. And then I'm going to divide by 2. So now comes the algebra part. So I might have written it a little bit confusing. If you write it on paper, you can do it a little bit better. First thing you want to try to do is get rid of that divide by 2. And the way you're going to get rid of it is by doing the opposite operation. So the opposite of dividing is multiplying. So what I did, so I'm right here, I multiplied this side by 2 and this side by 2. So 91 times 2 is 182. Multiplying this side by 2 gets rid of this divide by 2. So you're left with just 57 plus x. We want to get x by itself, so we want to get rid of this 57. The 57 is positive, so to get rid of it, you want to subtract both sides by 57. 182 minus 57 is 125. And then what you can go ahead and do is double check your answer. So do 125 plus 57, 125 plus, you get 182 divided by 2, and I do get 91, so I know I did it correctly. So I'm going to give you one more of those. So go ahead and try this one on your own. All right, you should have used your formula. The angle is 117, so I plugged in 117 for angle. Arc 1 is 150, arc 2 is x divided by 2. Just like before, we're going to get rid of this divide by 2 by multiplying both sides by 2. 117 times 2 is 234. Multiplying this side by 2 gets rid of that. We got 150 plus x. To get rid of the 150, we're going to subtract it from both sides. 234 subtracted 150, you get 84. You can go ahead and double check your answer. 150 plus 84 is 234 divided by 2 is 117. And that's about as hard as it gets. You're either going to be just plugging the two arcs in and dividing by 2, or you're going to be doing a little bit of algebra, but it's not going to get any harder than that. So go ahead and try your exit ticket now. If you have any questions, you can email me or join me for office hours. Hopefully this helps. I hope you guys have a really great day.